We will now go out through the ultrasonic screen. So if we're going to take an ultrasonic measurement, we will hit the ultrasonic button. There's only one screen that you can take an ultrasonic test in, as opposed to TEV where you had 6 and possibly 8 screens, depending on if you had the other sensor. Okay, so to do ultrasonic testing, what you'll need is your +2 in ultrasonic mode, and then you will need your headphones. So to plug the headphones in, we plug this into the bottom. And I can already tell that sound is coming in through these headphones. I can hear it with my own ears. When I first plug that in, ultrasonic sound will physically be coming through this microphone here. So if I scratch that microphone, there's a whole bunch of sound coming out of my headphones, and you can see on the screen here that my decibel level goes up. Now you can test all your switchgear with that microphone. There's nothing wrong with that at all. The next sensor that you would use is this one here, which is called your flexible microphone, which is an airborne sensor, same as the last one. What we do with that is we plug it into the side. With these, just be very careful to get them into its right direction when you plug it in. So the way you do that is there's a little tab on the bottom, the red dots face down. So we put that, we locate it, and then we simply push it in. It doesn't take too much pressure, and then to pull it out, you basically pull on that, and that comes out quite neatly. Okay, so now what happens is the instrument knows that I've plugged that in, because you can see on the screen here there's a little icon that comes up. That's the flexible microphone sensor. And then what we do with this is flexible. That's the microphone, and what we will do is we will scan our switchboard with that. We listen through all the air paths to see if we can hear any PD. Then if we don't have any air paths, we use what's called the contact probe, which is this one here. Now this is an ultrasonic tester. It's not a TEV tester. Some people use it to test for TEV, but that's not the correct use of it. So what we do is we plug this into the side. We then plug the other end of that lead into our contact probe, like so. And then what we will do is we will place that onto the outside of our switchboard to listen for PD on the inside of the switchboard, or whatever you're testing. Now the sensor itself is this big round circle in the middle. When I touch that, I can hear sound coming in through there. These little circles you can see on the outside are rare earth magnets, and they hold this onto the switchgear if it is a ferrous material, and the magnets stick to that. The instrument knows that your contact probe is plugged in because that icon has changed. The reason that's important is because when you do a recording, the recording will tell you what instrument was plugged in, or what accessory I should say. Then the third type of sensor is this one here, which is my parabolic dish. This one has a laser. To turn the laser on, you push this button. Everyone enjoys the laser. But what this one does, it will test for PD signals from a distance of around about 20, maybe even further meters away from the source. The way that it does that is you point and shoot this out in the field. All the sound will hit the parabolic dish and reflect all of the sound back into the microphone, which is just in there. So all the sound comes to the dish, bounces into there. And then you use that the same way you use your airborne sensors. You'll point that at anything you've got an air path between you and it, and the phase plot will come up on the screen. So now let's talk about the screen. So what you've got is you've got a decibel microvolt level. That's how our ultrasonics are measured. We've also got an algorithm that's running here, and it's telling me that there's noise coming into my microphone at this point in time, which is correct. It's not measuring any PD right here in this room that I'm in. Now the algorithm will listen to the sound and the sound only. It doesn't care about the decibel level, it doesn't care about the phase plot, and it doesn't care about what accessory you have plugged in. Okay, so the algorithm works really, really, really well for all your airborne sensors. With the contact probe, just be mindful that vibration could be trying to trick your sensor, and hence it can also trick your algorithm. Okay, so let's go through our options again. We've got our settings menu. Again, we can change what we want to hear through our headphones. So default is ultrasonic. If I change that to TEV, it will start to listen to TEV. You don't want to do that in this mode. You want to keep it on ultrasonic. Again, we can change if we've got a photovoltaic where we're looking at the lights. We can change if it's an E-field lock. We can change if it's a wireless lock, or we can change if it's a manual lock. And again, we've got that persistence mode where it will constantly refresh the phase plot. You can see that here, how it's resetting the phase plot over and over and over. Okay, and that's how that one works, but I'll put that back to infinity for myself. And that's all the ultrasonic tests.